Hello, geometry students, and welcome to the continuing lesson on lines and transversals. And you can see here in some of the notes we already made some definitions, but now we're going to get to the more complicated part. And I'm going to use one picture for all of this. And just so that we get some practice, I'm going to deliberately use a somewhat difficult picture. So I'll call this line 1. This next part here, I'll call it line 2. And then this line here, I will call line 3. And let's look at our definitions here. It says a transversal is a line that intersects two or more coplanar lines at different points. So in this picture, all three of these lines, line 1, line 2, line 3, can be considered a transversal. Line 1 intersects line 3 and line 2 at two different places. Line 2 intersects line 3, and it also intersects line 1 over here. So all three of these can be considered transversals. Now, in order to talk about the rest of these definitions, we have to name one of these lines the transversal. So I'm going to name line 3. Okay. We don't have to name this way, but I'm going to. Okay. So then, now we can look through these definitions. Oh, I'm sorry. I'm also going to number these angles. 1, 2, 3, 4, 5, 6, 7, 8. Because I've named the line 3 here the transversal, now we can define what's called the interior and the exterior of this particular situation. So the interior is defined as the area in between the two non-transversals. So this shaded right here, this shaded region right here is the interior. And then everything outside of this is considered the exterior. So our first definition here says when two lines are cut by a transversal, two angles are corresponding angles if they have corresponding positions. And this is a bit of a silly definition because it uses the word corresponding to define corresponding angles. But maybe we can look at it this way, and I'll start with an example. Angle 1 and angle 5 are corresponding. And the reason this is true is because they are on the same side of the transversal. They're both on the right side of this transversal. 1's over here, 5's over here. One of them is on the outside, or the exterior, and the other is on the inside, or the interior. And if you look at them, they have the transversal as a ray. So angle 1 has this ray that goes up and a ray that goes in this other direction. Angle 5 has a ray that goes up and a ray that goes in some other direction. Okay, and the key is they're on the same side of the transversal, and one is in the interior and the other is in the exterior. So if we apply the similar idea, we can also see that 4 and 8 are corresponding angles, as well as 2 and 6, 3 and 7, and that's about it. We've sort of exhausted everything. So these tick marks here just mean same as above. So those are our corresponding angles. And these are probably the most difficult ones to point out based on the definition. The other ones are much more straightforward. So let's see. When two lines are cut by transversal, two angles are alternate interior if they lie between the two lines on opposite sides of the transversal. So they have to be between the two lines or in the interior. Okay, that's what between the two lines essentially means. It means the interior. and they're on opposite sides. So 3 and 5 are alternate interior. Now you might think, why aren't 3 and 4 alternate interior? Well, they can be by this definition, but they're already linear pairs. There's something much stronger that we can say about them. So we don't include 3 and 4 because they are already linear pairs. So we're going to go with 3 and 5. Okay. So angle 3 and angle 5 are alternate interior angles. Also 4 and 6. And that's about it. That's all we can say for this particular picture. Continuing on, two angles are alternate exterior if they lie outside the two lines and on opposite sides. So 2 is outside, 7 is outside, but they're on the same side of the transversal. They're both on the left. So you want to go with 2 and 8 here. So angle 2 and angle 8 are alternate exterior angles. Okay. Also angle 1 and angle 7. Okay. Now you might also ask, why aren't 1 and 2 alternate exterior? Well, they kind of are, but they have a much stronger relationship. They're linear pairs already, so we try to we really just exclude that from this definition. And lastly, two lines are cut by transversal. Two angles are consecutive interior angles if they lie between the two lines and on the same side of the transversal. So between the two lines, so they have to be in the interior, and they have to be on the same side. So that's 4 and 5. Are consecutive interior. And also 3 and 6. Okay. And there you have it. In this picture, we have clearly defined all of these angles and given the definition and given some examples for all of them. And again, I want to point out this works as long as you have a clearly established transversal. If we were to use line 1 as a transversal, everything would be different. In fact, I invite you to think about the same picture. What angles would be matching these definitions if line 1 here was the transversal? And we'll go through this example in some more detail in class and as well as in your homework assignments. Thank you for watching and have a wonderful day.